Welcome to the Defeating Epilepsy Foundation YouTube channel. In this presentation, we will discuss what the basal ganglia is, the functions of the basal ganglia, what can happen if the basal ganglia is damaged, and treatment options. Make sure to like our videos and subscribe to our YouTube channel. Click on the bell to be notified of future videos. Please click on our donate link in the description section below and donate today. Your donation helps us to make a difference for those battling epilepsy. We appreciate your support. The basal ganglia are a group of structures lodged between the cerebral cortex and the brainstem that control voluntary movement. It is comprised of the caudate nucleus, globus pallidus, nucleus accumbens, putamen, substantia nigra, and subthalamic nucleus. The basal ganglia mainly acts as a filter for information going to the motor cortex. Through different circuits, the basal ganglia can promote certain motor signals and suppress involuntary movements by sending only relevant, converted projections to the cerebral cortex and other areas of the brain via the thalamus. In other words, the basal ganglia plays an incremental role in processing and propagating brain activity. The basal ganglia also performs non-motor functions related to procedural learning, habit formation, attention, reward-related behavior, and emotion. Damage to the basal ganglia nerve cells will result in the progressive degeneration of motor functions. This can translate into uncontrollable limb movements, a loss of balance, tremors, spasms, gait problems, poor coordination, trouble walking, and other movement disorder symptoms. Non-motor capabilities can also be affected by injury to this area. Notable examples include vision difficulties and speech impairment. Basal ganglia dysfunction is associated with several medical conditions, including Wilson's disease, multiple system atrophy, Parkinson's disease, progressive supranuclear palsy, Huntington's disease, and multiple sclerosis, to name a few. Involuntary movements caused by damage to basal ganglia structures might resemble and be mistaken for epileptic seizures. Unpredictability is a common feature of both seizures and movement disorder contractions. However, basal ganglia-related movement disorders are not generally accompanied by a loss of consciousness or awareness. There is a body of literature that postulates the caudate, putamen, nucleus accumbens, and pallidum are involved in temporal lobe epilepsy. Rector and colleagues suggest that while there may be the case, it is unlikely that the basal ganglia contributes to the production of clinical seizures, considering that no epileptiform activity has been recorded in this brain region. Instead, evidence suggests that the basal ganglia plays an inhibitory role during temporal lobe seizures. The extent of this involvement, however, is still poorly delineated. Research speculates that the basal ganglia plays a role in influencing and spreading electrical brain activity via feedback pathways. Imaging studies have suggested an association between the basal ganglia and epilepsy through dystonia, a prevalent feature observed in mesiotemporal epilepsy, characterized by involuntary muscle contractions. Dystonic posturing is suspected to result from irregular activation of putamenal and extratemporal cortical areas during temporal lobe seizures, inferring that the basal ganglia affects the propagation of seizures. Treatment options very much depend on the condition affected by basal ganglia damage. Even though the basal ganglia does not contribute to the production of epileptic seizures, its involvement in information relay could direct future research into new pharmacological avenues. Researchers already have been looking into introducing anti-epileptic drugs to treat hyperkinetic movement disorders, which are characterized by excessive, uncontrollable limb activity. The basal ganglia is a network of subcortical nuclei that propagates motor information going to the cerebral cortex. An injury to this brain area will affect the execution and control of movements. Basal ganglia pathways might enter the neurocircuitry and play in epilepsy, but it does not contribute to the genesis of epileptic seizures. To learn more about the basal ganglia, please check out the resources used in the presentation today. Please like and subscribe to our YouTube channel and follow us on our social media pages. We would love to hear from you. Leave a comment below or email us at info@defeatingepilepsy.org. Thank you for your support, and together we will defeat epilepsy. Check out our other great videos and subscribe today. You have the power to defeat epilepsy.